Okay, we're going to use trigonometric substitution to evaluate this definite integral. When you use trig substitution, I like to remember that you're going to use sine, secant, or tangent. I remember SST. So I'll draw a little right triangle. And what we want to do is when we use this trig function, we want the x to be in the numerator of the trig function that we use. And we don't want the radical to appear there. So by the Pythagorean theorem, I can label the sides of this triangle as 3, because 9 minus 25 x squared, square root of that would be this leg. Okay, so the sine of theta is 5x over 3. That's what we want. X in the numerator, no radical. And now if we solve for x, we get, this is a 3/5 the sine of theta. Dx is then 3/5 the cosine of theta d theta. And here's where the trig substitution starts to work. We eliminate the radical. So 9 minus 25 times x squared gives us this. We can factor out a 9, and 1 minus sine squared is cosine squared, so the square root is 3 cosine theta. Now remember, that's just the square root. This is raised to the 3/2 power, so in the end we'll be cubing this when we do the the theta substitution. So this is the denominator. You could solve for theta here by saying theta equals the inverse sine of 5x over 3, and then you could replace the limits of integration as you go through the substitutions. But for this video, I will take us all the way back to the antiderivative of this thing. Okay, but like for example here, you could say when x is 0, the angle that has a sine of 0 is still 0. But when x is 0.3, if we put a 0.3 in here, we'll end up 3/10 will be taking the inverse sine of 1/2, which is pi over 6. But then when we do the u substitution, down here we'll have to replace those limits. Okay, but again, for this video, I'm just going to take us back to the antiderivative here. Okay, so here's the x replaced with 3/5 sine of theta. Here's the dx replaced with 3/5 cosine of theta d theta. And here's this denominator replaced with 27 cosine cubed theta. 3/5 times 3/5 in the numerator is 9/25, which I factor out. Factor out the 27. We can figure out what this is in a bit. And then one of the cosines cancels out, so we get sine theta over cosine squared theta. Now, where did these minus signs come from? I'm going to use u substitution. Let u equal the cosine of theta, du equals the negative sine of theta. So I put a minus here and a minus out front. And minus 1/75 antiderivative of du over u squared, or negative 1/75 antiderivative of u to the minus 2 du. So the antiderivative here is minus u to the minus 1, which I can write as 1 over 75u. And again, if I had replaced these limits, which I think this would have been a 1 and this would have been a radical 3 over 2, we could evaluate this from 1 to radical 3 over 2. I'm not 100% sure about that, but I think that's what it is. Okay, but if we go backwards, I'll replace this u with cosine of theta, and then cosine of theta, well, I look back at this right triangle. That's why I draw it. Here's theta. The cosine of theta is this radical over 3. So there's the cosine of theta right there. This 3 goes into 75 25 times. And now this is what I'm evaluating to 0 to 3/10. Okay, and this is one way to the denominator and write it a little bit differently. I think you get like 2 minus the square root of 3 over 75 radical 3. And you could rationalize, blah, blah, blah. But there you go. Hope that helped. If you have any questions, post a comment.